Now for the next fourth sum. A well of diameter 3 meters is dug 14 meters deep. The earth is taken out from it and is spread evenly all around it to form a circular ring of width 4 meters to form an embankment. Find the height of the embankment. So here we have the well, which is a cylinder. This is the well and it is a cylinder. And we have another, here we have the embankment on the top. This well is dug out, means all the mud from this well as it is being dug has been removed, and the mud is then put around to form the embankment. So we know volume of well will be equal to volume of embankment, because the mud from the well is put around the well to form an embankment. Now we have two kinds of cylinders here. One is we have the well. This is the well here, which is a hollow, which is a cylinder. And for this well, we know the diameter is given as, this diameter is given as 3 meters. So the diameter here, 3 meters. So the radius will be 3 by 2 meters. And the depth of the well, this depth of the well is given as 14 meters. So we have the height of the cylinder is 14 meters. Now let's have a look at the shape of the embankment. Now if you see the embankment, it is not a full cylinder, it's a hollow cylinder, because in the middle it is hollow, in the middle is a well. So it has got an inner radius here, inner cylinder here like this, and it's got an outer here, right? So this is your embankment. We will draw it again. So here I've drawn the embankment again. So this is our embankment here, okay? So we've drawn this here, this is the embankment, and this is how the well is here. The well is here, fine. Now we know in this case volume of embankment or volume of well will be equal to volume of embankment. Why? Because all the mud, all the mud from the well was removed to make the embankment. So we had volume of well equal to volume of embankment. Let's go to the dimensions again. Here we have the inner radius of the well, which we already saw is 3.2. So we have the small r is 3.2 meters, which is the same thing here, 3.2 meters. Then we have the outer r. Now we see the outer r will be the small r plus this thickness, plus the thickness here, or the width, the thickness or the width of the embankment. So your outer r will be 3.2 plus the width of the embankment is given as 4. Okay, so your r will be 1.5 plus 4, and that will be 5.5 meters, the outer r. And the height of the embankment is what we need to find, and the height of the well is given as 14 meters. So let's mark the figure, the dimensions again. So we here have the inner radius r of the well is given as 1.5, that is 3 by 2. So r 1.5 meters. It is the same as this r. So the r is 1.5. Now we have the outer r. This is the r, or called the outer r, the outer radius. And you must have seen that the outer radius is made up of the inner radius plus this width of the embankment. So this R, the outer R, will be equal to inner plus the width of the embankment. So equal to 1.5, and the width of the embankment is 4. So the outer R equal to 5.5 meters. Now let's look at the height. This height of the well is 14 meters and we call it as H. So the H is 14 meters. While the height of the embankment we do not know, and that is the question. So the height of the embankment is a question. Now the equation we made was volume of well was equal to volume of embankment. Why was it so? Because we saw that all the mud from the well was removed and was used to make the embankment. So what is the volume of the well? Well is a cylinder, so it will be pi r square h, and the embankment is a hollow cylinder. So embankment will be what? Outer volume. It will be outer volume, that's outer cylinder, minus the inner cylinder. This will be your embankment. Remember, it is hollow in the middle. So it would be pi outer, that is pi r square h, minus pi r square h, outer volume minus inner volume, because remember it is hollow. So let's continue. So we have pi r square h equal to pi r square h minus pi r square h. We'll take pi common out and we have pi here. We'll take pi common out here, pi h common out here. What will remain inside? R square minus r square. Now this pi cancels out and you are now left with r square h equal to h r square minus r square. We put the values, 1.5 the whole square, and your h here is 14, and this h we need to find out. The outer h we saw r is this one. See, the outer r is here, we have 5.5, and the inner r we have here 1.5. So we have 1.5 square into 14 equal to, now a square minus b square, a minus b into a plus b. So we have 1.5 square into 14 equal to h. Now when you subtract this you will get 4, and when you add here you will get 7. So your h, and that's what we need to find, this h will be 1.5 into 1.5 into 14. This 4 comes here and this 7 comes here, which is equal to h. And the h is 1.125 meters. So this embankment here, this height of this embankment is 1.125 meters. Let's go back to the picture. Now this embankment, we found the height is 1.125 meters. And the key of the sum is this: volume of well equal to volume of embankment. For volume of well was just pi r square h, but embankment was a hollow cylinder, and because it was in hollow cylinder, it was outer volume minus the inner volume.